Hello everybody. In this tutorial, I'm going to explain the images experiment that you can find on the PsyToolkit lessons. And here I want to take you through it. First, before I explain the experiment, which I have here in my account, I will compile and then run the experiment. When you do that in the in your account, you also always can go back to the experiment editor. If you do this as an experiment with participants, it wouldn't be like that. But let's get back to that. So if I click this, for example, I'll go just back here. But for now, I want to run it actually. So run the experiment and click to start. Now it's a very simple experiment. Uh, you can put it in full screen, and um, on your real screen, it might be a little bit smoother because I'm recording here from a screencast. But basically, uh, first we start with an instruction screen, as most experiments do. And this one, this experiment is completely mouse or tapping oriented, and that's a good thing for this type of experiment, I think. So in this experiment, you see a fixation point, and then you see an image. Participant sees an image. Then underneath is a message. Do you agree that this dock is approachable? And the participants can click on the yellow slider and move it from disagree to agree. And once they're done with their decision, for example, I would say agree, it's very cute doc. Then you press OK, and then there is an animation, and then the next picture shows up, and it goes on like this. So this dog looks a little bit more maybe aggressive. So you would say, well, maybe, well, I don't think this dog is approachable. And then and we do this task quickly. Do you agree this dog is approachable? Well, maybe somewhere in the middle. Um, and then we don't think this is approachable, and there are 10 images. So in total there are 10 images, and each image is only shown one time, and the score is actually between people don't see that between 0 and 100, and we will explain how this works. So let's first just finish these 10 trials, and that takes only a few seconds, and we're almost done. Just quickly finish this. And you also should know these images come in random order. Now, if you do this in your own account, the first time you can also save these data on the server for later download or analysis. You actually want to do that one time. We'll come back to that. Actually, if you've done that, you see what a data file looks like. The output data that will be created by this experiment looks as follows. There are 5 columns. The first column is the from the from the which image it is, basically 1 to 10. The second column is the reaction time. The third column and the fourth column are sort of like descriptors, and the fifth column is the score on the slider. And how that's created, we will come back to that. So for now, I'm going back to the experiment and explain the code. Now, when you watch this, by the way, I hope you have done simpler experiments in PsyToolkit, because this actually is really fairly advanced. It's very doable, but in order to really understand it, you should look at simpler experiments first, I would say, to really get to grips with PsyToolkit experiment coding. Now, what is important, if you look at this, whenever you make a change in it, the background becomes sort of like reddish brown. If you press Ctrl S or click the save button, it will be saved. There are also views. You can click on view files. Then you see the images used with this experiment. Here we see the following. There is an image called button OK. That's this OK button. Then there are the 10 pictures of dogs that are used in this experiment. And we have a fixation point, that's an image, and then there's the instruction screen, and that's it. And also for the mouse animation that you see on every trial, the 1, 2, 3, 4, 5, 6, 7 steps of that mouse and the slider. We have a gray slider, actually it's not used. We use the yellow slider in this case. And we have a slider bar that's there. And the images, apart from the dogs, the images I drew with the Inkscape software. And on the PsyToolkit YouTube channel, there are several um, videos on how to draw stimuli with Inkscape. Now let's go through the code. First, we have an option line here. In options, you can set such a specific resolution that deviates from the default, or you can set a variable. Here we use set with a global variable. Global variable start with the and sign and ampersand sign, and then I call this variable ypos, and that's actually the position of the slider bar. And I just thought if I set it here, then I can easily change it without going through the code. So sometimes you might have constant values that you want to set in your options, not necessarily. Then we have every bitmap that you use in your experiment, you need to tell PsyToolkit that that is used. And we have a whole bunch. You saw them, of course, also in view files. Now you might say, why does this actually not work automatically? And the reason is that you can, in principle, upload more files to the system than being used in the experiment. And it's just quicker for participants to download uh, an experiment that uses only the images that you want to use. So that is really for efficiency. Now we don't use the extensions of the images. If you go on view files, you see, for example, doc1 is a WebP file that is a very efficient image format. But in PsyToolkit experiment, in the bitmaps, you only say doc1, and PsyToolkit figures out itself what the extension is. Now, and I want to take you through all the details here so that you learn actually on how to code, how I did the coding. Now, then, really important, I have created a table which I called table my conditions. My conditions, I don't. So if you have more than one table, you need to use this later, but now you can call it anything. And then in my table, I have basically two columns. The first column is a human descriptor, which actually consists of two parts. Uh, First of all, is actually the image number. So like if you want, then you can later up, and then so like a descriptor. Now I did this just for demonstration purposes. In reality, you would probably want to have this all balanced and so on. And then the actual image. So if I have doc1 here that refers to the image that we've uploaded, and images, when we upload images in PsyToolkit, we always call them bitmaps. That's just a different word. Now, really important, what we then have is here a task. And you see, I use indentation to just, that is just, you don't need that indentation, but it just makes it more readable. And everything that starts with a hash mark is a comment line. Now, I'll zoom in a little bit just to, uh, just for clarity on the video. First of all, if I do show a bitmap, then I just show an image that I've uploaded, and there's an image, fixed point. If you go up, you see it here, fixed point. It was uploaded, right? That was this yellow plus symbol that I uploaded as an image. And here, this is a human readable comment. This is my first stimulus, and each stimulus has a number in the sequence of events in one trial. So we show a fixed point. We delay, we do nothing basically for 500 milliseconds, half a second, and then I hide it. I could also clear it from the screen, but you can also hide stimulus number one. Uh, and that doesn't really, there are different reasons for doing that. That is not important for now. And then after that, after we removed or hit that first fixation point from the screen, we show a bitmap. This is something where it becomes a little bit more complicated. So bitmap, you understand. Add to here means add to, what does it mean, right? So that's the question. That actually refers to a table entry. Something that starts with an at sign refers to the second column of the table. Now, if you go back to your table, you see, I saw there's column one in quotes, right? That's the human descriptor, and column two is the image referral to the image. And so on every trial, every time PsyToolkit runs the experiment, it will take one of these rows at random, and it won't replicate because there are 10 trials in total and 10 table rows, and PsyToolkit then figures out that it should show everyone only once. So it shows, say, for example, on this trial, it takes dog 4 randomly, row 4, then add2 refers to image doc4. But if it had chosen this row instead, which it might do on another trial, which it will do on another trial, it will change add2 would revert to doc7. So show the bitmap as defined in the second column. Then these are the xy coordinates. Now, what are xy coordinates? 0 is the x coordinate. That means actually central on the screen. Minus 100 means a little bit above the fixation point. Now, if you want to know more about how this actually works, always recommend Command Overview. If you go to Command Overview, you get a quick overview in a new tab, and you can, for example, go Task Visual Stimuli Coordinate System, and it explains here 0, 0 means screen center. If the y value goes up, then you go more up here, so you can always look at that. Okay, so go back to the code. If you want to know how does show bitmap works, you can just go, okay, how do you show a bitmap? And it gives examples there. So it's a very easy to use this command overview button. Okay, once I've shown that, then now what actually then the more advanced stuff is starting. For first of all, we show 3 more uh, images on the screen, namely the image of the slider bar. And for this, we say this it's centrally oriented on the x on the in this in the center horizontally. The y position is as it was set to, you remember that was the value is 200. We set it at the top, remember here. Okay, so 200. So I could also just type here 200 instead, because but it's a constant. I thought, okay, it's actually for developing, it's sometimes easier if you have, if it comes back that value, just use a variable. Then the slider on the slider itself, this yellow thingy that you can move around, is on top of it. We show the OK button at the bottom, so we 0 270, and then we show the text that you show text, and then in quotes. Do you agree that this dock is approachable? Where again, so here the XY locations, and every time you don't need this, by the way, so in human readable text, so something that the computer ignores, hash mark, that's a comment, but I know that's the 6th column, and later I need to know that actually. Then some more text that you now explain, show disagree and agree, so that these labels on the left and the right. Remember, if we quickly save, and you can always quickly run the experiment that we just had, run the experiment. If we remember, uh, this is what it looks like. So you now understand that it's the image here, the slider. It's all all just these are drawn, and the reason that you can move this, that's because of something that's in the code later. So let's go back to the experiment editor, and we're now here. We've shown everything. Now we do the before people can use the slider, we actually do something really advanced as well inside Toolkit. We show an animation. You need to say where's the animation. This is 0 to 20, so that means a little bit below the screen, and then it is the whole animation takes 1200 milliseconds, and this is the order of the images that are shown then, and it's an animation. You show mouse 4, mouse 3, mouse 2, mouse 1, mouse 2, mouse 3, mouse 3. So that is basically a trick. Then if you look at view files, here you see all these different mouse 1, mouse 2. So if you show these quickly after one another, it looks like an animation, right? So that's what we do here. It's and PsyToolkit has that built in, so it's really easy to do an animation based on different images. Then we say clear -1. Now clear -1 is a standard thing that means show delete from the screen or erase from the screen the thing that I've shown just before -1 reverse. If you do -2, that would be show text degree and so on. -1, remove that because we show this moving mouse and then clear one. So now that we've done that, we're now having the following 1, 2, 3, 4, 5 lines where we tell PsyToolkit that people can drag something. We have ultimately the dragging instruction, but you need to set some things. So first of all, you say, okay, X, there are limits to where people can drag the thing that they can drag, and there's it can be dragged from -230 to 230. You can't drag it further. You can drag uh, except, between 200 and 200, right? So that is, you cannot actually move it up and down. It's always only horizontal sliding. Drag from, this is the stimulus that can be dragged. That is number 4. So this refers to here. Remember number 4, the fourth stimulus shown. Now you might say, well, why do you not just say drag option from slider yellow or something like that? But the thing is, you can show this bitmap multiple times. So this is actually, this refers to the number of the stimulus in this, what I call the stimulus stack in that specific trial, the fourth thing that was shown. And then you show the which stimulus is the exit button, and that's in this case our button OK. And then once you've set up these sort of like these options for the dragging, then dragging starts. And then when for basically, this is 9,999, that means basically 99 seconds and 999 milliseconds, basically 10 sorry 199 seconds, or that, that's roughly 1.5 minute. People can move this stimulus, only this one thing, that because I've set it up like that. You could set up, with dragging you can move around stimuli much more sophisticated, but for this is just actually, we use a trick here. This creates a slider bar on which you can only move around this yellow thing, this yellow slider top. Now once people have finished the dragging, and the dragging stops once people have clicked on the exit stimulus, you clear a whole bunch of stimuli from the screen. 3, 4, 5, 6, 7, 8, 9, but not the image itself. For that we have a for loop. Now if you do programming, you know this. So basically everything between for and for end happens multiple times. And here we say for, we set a variable, and when it starts with a dollar sign, it's a local variable. We could also write equally just end one here, but we don't. We use this. That means it's a variable that's being reset to 0 every new trial. It doesn't really matter whether you use this or an end persona, but you need to know that this is a variable. And then in 90 to 10, so it counts from 90 to 10 by steps of 5. And every time it scales the second stimulus to a value, and scaling to something, this is the percentage. So it's 90%, 80%, sorry, 90%, 85, 80, 75, 70, and so on, all the way to 10. So that image, this dog image, becomes smaller and smaller and smaller, and that's done every 25 milliseconds. And that just creates an animation. You don't need that, but these things just make the whole brings the whole experiment, I think, a little bit more to life. Now, once that's done, we quickly calculate some things. Participants are not aware of that, but so you actually drag X means what is the X location of the thing that could be dragged, and that was stimulus 4. What is its location? And that is, in this case, is the X value, the X location of this yellow thing, and that's now different, but that's still somewhere between -230 and 230. So if it's all the way to the left, it would be -230. So we have here, we set we set a new, so here we set just the raw score to draw X. That's just for later. You do not necessarily need this, but this is really important. Set the score of a new variable that we create. So we create this variable called score. We have an expression, and then you can have a formula. So we say drag X, which the lowest value is -230. So you see plus 230. That means it starts with uh, um, It starts with 0, and we divide that. So then it can go up all the way to we have minus 230, so 460. So you need to divide it by 4.6 in order to get a value between 0 and 100. That's just sort of like a transformation. Um, and it says here in human readable instruction, this way you get a score between 0 and 100. Now, once that's done, now the second fixation point needs to draw attention to text area, so this animation helps. I I think this is actually no longer relevant. I had some other additional code probably. I can remove this even. And then we have save table row, RT, add 1, and score. What does that do? Well, see, the raw score that I had here, actually, I don't even need it. I never used it. I could save it, but uh, for analysis, I don't need it. So here, table row. So that's just the number, the table row that was selected on this given trial, the reaction time on this trial. How long did it take me before I clicked OK? The human descriptor, which would be actually consist of two elements separated by space, so dog1 and adorable, for example. And then the score. Okay, so that's it. That happens multiple times. Actually, this task is carried out 10 times. So now in a block, we always say how and when trials are selected. So in block, we call it test, we could call it training, we could call this anything. I have first have the so-called message instruction. If you want to know how that works, go to block instructions message. You get instructions here. Um, now, this, if you do it like this, you show the instruction bitmap, which fills the whole screen, and you wait until people click the mouse somewhere. And then the task rate images is done 10 times. If you want that it comes in fixed order, you can add this fixed, and then it goes row 1, row 2, row 3, and so on. That comes in fixed order. So sometimes people want that. And that's it really. So that explains everything. But what I also want to explain is analyze. Click here to analyze the data you saved. If you want later, you create a survey, and we will do that in a second. You need to tell PsyToolkit one time how the output data are organized. So we already have a file here. And but how do you do that? In this case, I would want to know for, say, the different categories of dog. So that's column 4 in the output data. I want to know what people's score is, which is in column 5. So how do I do that? So here's which column has a dependent variable. That would be column 4, right? No, column 5, the score. The score, that's here. Do you want to consider only tries which follow successful trials? Well, in this specific type of experiment, we don't have errors, so you can ignore that. Which column has the status correct? Ignore it because you don't have that. Which value is correct? These things are, if you don't understand it exactly, read this. Um, Grouping variable, well, that would be column 4, so like this, in this case, the category of dog. And then the other things in this specific case are irrelevant. We There are lots of options. You save the parameters, and actually it runs it only for these given example data, and then it gives you some data, in this case the mean value. Now you need to set this up one time, and then it works. You can now forget about this. You have set it up with, the reason you need to have one example data file is simply so that so that you know for sure that the data analysis will work. But now let's imagine that we want to send out this experiment to participants. How do we do it? We create a new survey. We call it, say, my doc test. Create a completely new online survey. Now, when you do that, you get into survey mode. This is a different scripting language, as you probably already know if you've worked with PsyToolkit. If not, if you see this for the first time, this looks cryptic. Now, uh, in PsyToolkit, you create questions, and they are in a scripting language. That's nice because this makes it easy to copy and paste. If that, but beginners, I recommend you work in the easy mode. So let's do that. So if you do it in the easy mode, you see, for example, there's a question age. You can click on that. Then it explains what it is the question. How old are you? You can even get a preview, and then this is what it will look like to participants. Okay. Um, so I'm happy with that question. So easy mode overview. You have a gender question, and what I want to add is an experiment. Now, if I want to add it before age, I would press the plus here, but I want it afterwards, so I press this plus. Then you have lots of options, but we want an experiment, so I click here, click on experiment, and then you can read through it, but select one experiment from the list below. Now I have multiple experiments, but it's the top one in this case, and you can need to give it a label. It automatically does it if you work but I can call it also my experiment. It doesn't really matter. Save question. Now I can also go to the regular overview with this more cryptic language. Read through it. If you want to know more on how this works, tip on scripting help. It explains how this all works. Now it's not yet ready to run. So in order for one time you always need to compile it if you make changes. So you compile it, it says uh, it was compiled successfully. That means it's runnable. We haven't yet made it online, so we make it online, change survey status, and now you get a URL that you can even make it into something that you can hang up in the university. Uh, but you can also copy this to the clipboard, and then you can send it an email or put it on social media. And we can test the survey. Now, if I would test it, you get about the study information, but it doesn't give much information yet. But if I would start it, I would get these questions, so you can answer them, uh, and then after that, you get the task. Okay, and you could program it so that it automatically goes in full screen. Um, you just use the full screen option, but right now, I could go through it and uh, well, maybe I should do that so that you also see that the data are saved. So I quickly do it just so um, so that you see that data are saved. Well, I should give some values here. And we have it almost ready. The adorable Bichon. Of course, all these dogs are probably really nice, but the point is, it's just an example. And then this always comes at the end. So once people see this, they can close it. Now the data are actually saved on the system. If you go to download, it says currently no data files, but that's just because the screen has not been refreshed yet. Because these are just new. If I type Control R or just click here on my doc test survey again and I go to download, it will actually see there are currently one data files, uh, and you can then download it. If you download it, and because I've set the analyze section, you get you get spreadsheets for all the data, and there are more tutorials on how to analyze it, but that should be fairly straightforward. So I hope that helps. If you like this type of explanation, please like and subscribe, because this is actually made by academics for students and academics and researchers. And that's great, but it only works if people also actually support the system, for example, by subscribing. And I hope it was great. Thank you for watching. If you have questions, uh, email me. My email is on the main website of PsyToolkit, and we always like to help people if we get questions. Also, we have online courses, so you can subscribe to that if you want. But feel free to send me a question as well if something's unclear. Leave a message under the video. That's also where you can post a question, and then I can answer it there. But if it's a detailed question about your experiment, send me an email. Okay, goodbye for now, and note that there are more tutorials on this channel.